Now, again, chapter 5, laws of motion. So, in our day-to-day life, we experience this thing whenever we want to change the state of motion of the body. It implies that if the body is stationary, steady, and we want to give it some motion, or if the body that is in motion and we want to stop it, or we want to change the state of motion. So in that particular case, we have to apply the force. So we can say force is such a physical quantity with the help of which one can change the state of motion of the body. Okay. Now, there must be the external agency which can provide this particular force. Now, the force that is divided in two categories, contact force and field force, right? In some cases, to change the state of motion of the body, we have to establish the contact with the body. Say, for example, a book is lying on the table and you want to move it. Then you have to exert the force, but you have to touch the book. Without touching it, you can't do it, right? So when the external agency provides the force to the body by touching it, by establishing contact with the body, then it is called contact force. And when external agency provide the force to the body without making contact with the body, the force is called field force. Here we can take the example of gravitational force, electric force, magnetic force, like that. Okay, so all these forces are such forces which provided by the agency to the objects but without making contact with the objects. If any object is placed in the gravitational force field, automatically it will move towards the surface of the earth, right? If we have any magnet, and in the vicinity of magnet, if we place any object of iron, then it will be attracted towards it. So here, without making contact, the force exert on the body, and that is called field force. Clear to all of you? Initially, scientist Aristotle represented a law of motion, but this particular law of motion represented by him just by the observation of the motion of the body, right? એટલે કે એને જે દેખાતું હતું એ પ્રમાણે એને represent કર્યું. જેમ કે અત્યારે આપણે પણ એ વસ્તુ જોઈ શકીએ. Suppose you are cycling, then if you want to sustain the motion of the bicycle, then continuously you have to pedal it. Okay, so you feel this thing. Yes, to sustain the motion, to keep the body in motion, the external force is required. So this one is just merely by the observation, you can say it. And Aristotle also suggested the same thing. An external force is required to keep a body in motion. But this particular law was failed after all. Because after that, Galileo performed some experiments like this. See, as shown in the figure, the experiments were performed. Now, at the top of the inclined plane, a sphere was placed and then allowed to move Then he observed this thing, motion of the sphere, that is accelerated one. It implies that at it move in downward direction, its velocity is continuously increasing. But suppose it is allowed to move on that particular inclined plane from bottom to top, then the motion is retarding one, decelerated one. As it move upward, its velocity is continuously decreasing one. So if we take two inclined plane like this, so from top of one, when the sphere is moving in downward direction, the motion is accelerated one, and on other side, when it move from bottom to top, its motion is decelerated one. So he thought about the intermediate stage. Means between these two, if we consider the plane surface, then motion of the sphere on the plane surface, that can be considered with zero acceleration. That will be considered as zero acceleration. Okay, means it should be with constant velocity, because as this one is moving in downward, velocity is increasing. At the bottom it is maximum, and then after on the plane surface we can treat that maximum as a constant, and then after on other side when it is moving upward, so it is decreasing one. Clear? Now then after he represented another experiments in which the inclined planes were taken as shown in the figure. In first case, the inclined plane were taken such that on both the side, the height of the inclined plane, that is the same one. So he observed this thing, the height from which the object is released, then when it move on the other side, it attain the same height if the surface of this particular inclination, that is very smooth one. Then if on one side the angle of inclination is decreased, then he observed this thing, no doubt if the object is released for a particular height from one side, on other side it attains the same height but it covers some more distance. And if on other side the angle of inclination is made zero, it implies that the surface is made horizontal one. Then if the sphere is released from the top of the inclined surface, then when it reaches to the horizontal surface, it moves up to infinity. So with the help of all these experimental observations, he suggested this thing. The external force is not required to sustain the motion of the body, right? Why it is required? Because some other forces are acting on body, and he represented here the law of inertia. And law of inertia, that says this thing, if the net external force on the body, that is zero. Net external force means the vector summation of all the forces acting on the body, that is zero. Then if the body is in rest, it will remain in the resting position. And if body is in motion, then it will continue to move with constant velocity. This particular characteristic, or we can say property of the body, that is called inertia, right? So inertia means what? Inertia, that is the feature or the characteristic of the body due to which it resists or opposes any type of change in the state of motion, right? So if body is steady or stationary, then body itself have tendency to remain stationary. And if you exert some external force to change the state, then it will be opposed by the body. This is called inertia after all. Clear? So if body is under the effect of some external force, then and then only the state of motion will be changed. Otherwise, not. So this is the law of inertia. Clear to all of you?